This is 85 meters diameter, 77 free span. Took 1,000 seconds on a $25 million crane, which is less than our telephones today. And it's unbelievable the evolution we have and the power that was only on a university, that we single mortal engineers who are not professors, just practice people, we can have fantastic machines running 64 gigabytes models today. This roof is only 9.5 kilos per square meter of steel. This is even less. This is in the middle of the Guanabara Bay since 1997. It's Marina Gloria. Rock in Rio, we had a lot of experimentation with the 88 tits. It's 88 tits, and the milk were music, and music as the last language. So it's always the idea of making expression with the membranes and having difficult shapes transformed into reality. This main stage was in Guinness Book, 88 meters open front and 10,000 meters membrane roof. We had 1,200,000 tickets sold on this Rock in Rio festival. This membrane, supported by air, inflated spheres, was built in 12 hours and unbuilt in 6 hours inside the football field from Wednesday to Thursday for an event Friday and a football game again on Sunday. So speed was everything. This is the inside of it. And we had girls dancing in the inflatable balls. So we got a prize for this job in the top of the Sugar Loaf. It is designed for 250 kilometers an hour. It is at 250 meters above the ocean, and it takes all kinds of winds you can imagine up there. And also, every project I've built since January 97, because of global warming, I am increasing the pressure per square meter by 1.25. As a sailor and a surfer, I tell you the wind gusts we have today are stronger than the wind gusts we had at that time. Stop it here again. Here. So this was built on the top of Sugar Loaf with no cranes. We have to create jigs and ways to put it up there and transport all the parts by cable car. I really like this shape. It has the archetype of the Sugar Loaf. This arch is 180 meters in length, and it was again analyzed by ANSYS, and we are using very much fluid structure interaction. We are doing very much wind tunnel tests with CFD. This is for Petrobras, a lot of membrane roofs. Most of the material we build, we use Ferrari 1202 T2 material, which is a very good material to work. This is in the middle of the favelas in Rio. You can spend days telling histories on how it is to work in the middle of the drug dealers, but well, we survived that. This is the quality of our manufacturing, and this is one area of my love and interest is the evolution of CFD and wind tunnel design and the ability to transport. And every single drawing we put up, we do a CFD test just to keep sharp. Even if we are making just a doghouse, we make a wind tunnel test. This now is a patent. We have a worldwide patent for the solution of covering a ship. It will be the largest cantilever in the world, according to most engineers we know. As far as I know, the largest cantilever was 82 meters up to now, and this is 128 arc length and a free cantilever of 98 meters. This is in Santos, where I'm living now in São Paulo state. And this is a very important job, although each unit costs 85 million. There are 2 units. They get payback by efficiency in 1.5 years. This is the CFD wind tunnel and the comparison to the physical wind tunnel. I have now the happiness of comparing CFD to physical wind tunnels, more or less nearly a dozen cases. And we came to a correlation of the CFD results to the university wind tunnels, it's funny, they're always 10% less. So we multiply the CFD results by 1.1, at least, to be equal to the results of what I think is a safety factor from the guys who make the physical models. Because it's funny, that's always very near 10% in 12 cases. I have a feeling the CFD is correct, but since the correlation to the wind tunnel is that, I'm multiplying CFD by 1.1. So this is the ANSYS analysis. We do solid models in the areas of interest where we can see the tensions, and we do eigenfrequency of megastructures. These models are very big. I tell you, we have models with near 60 gigabytes to have all solids. Even these models, we cannot have solids everywhere. So we have beam elements and solids mixed because we don't have enough computing power to have it as we would like to. But it's much better. This is a case for Petrobras, 30 meters high, 14,000 square meters, where we have, this is the drawing, this is the final constructed. This is a temporary roof to build a refinery on it. And this, on the left side, you see the wind tunnel applied pressure and the fluid interaction applied to the structure. So we do normally 16 cases, 18 cases of wind, and now we can do this in like 10 days. We can have a full model, full wind tunnel, full calculation, and go to production, which is the idea to be training fluid structure interaction. So this is a very ugly job. It's a just practical solution to cover a pipe shop in the middle of a refinery. But it's an engineering task to do it very fast and light to be a temporary structure. This Maracanã, where I have the happiness to be the responsible engineer for the building up. Our company got the job of manufacturing the membrane, cables, and helping in the management for the installation of cables and the ring. The design was made by the German group SPP, and I'm very happy to be there during this unbelievable task of reducing our contract time from 4.5 months to 56 days. Because all the Egyptians, the 6,300 men that were working there, building the concrete, everything, they delayed, and we are the last guys to go in. So our 4.5 months were not there anymore. And over these 35 years, I tell you, time is the most expensive of the assets. If you want to buy time, it costs to the square. So if you want to cut time by 2, you have to increase manpower by 4. So we went from 43 men to 203 men to make this happen in 56 days. The castings were made in Spain by Visa. The cables are Swiss. The membrane is Saint-Gobain, and we had the safety net below the whole construction put up by Irata Type 3 climbers. We had a team from 9 countries working together. And it was a fantastic honor. I'm honored to have had this task. I also have the honor to have my son working with me there. So this is one of the most important tasks of my life. And then I say, what next? What next? We did then Beira-Rio, 65,000 square meters, and I was hired as the check engineer. And again, we went on no time. We went on fluid structure again, and we did the eigenfrequency, and the structure had to be reinforced. There were a lot of buckling, and this structure was initially budgeted by 2.93 thousand ton, ended up with 4.3 thousand ton, but it will stand and it will resist the winds and the vibrations. It was a big task to convince the guys to spend 1 million kilos of steel more, I tell you. It took days, many days. But I told them, you're not going to be front pages, not on the wrong one. So this is the first membrane, and here it was even worse. Our contract for 65,000 square meters of membrane and cables, and 65 different axes, no regular pattern. We made 65 equal petals, and we have to make 65 different infills because it was built over the year and there are no regular axes. Our 6.5 months contract became again 60 days. And then we had to go 9 times the group of people to be able to reduce the time. So this is here in Brazil, a hospital, and again, fluid structuring interaction. This is the train station for Maracanã. Also on share fuel type 1 from Saint-Gobain. It's one of the heaviest materials you can have, but it's a very flat design and you need very high tensions to keep it up. Now what next? What next? What I'm dedicating myself for the next years, I'll be working on tensile structure apart from roofs. Environmental solution. This is a net made by Ferrari, and we are using this as a project to hold metal dust from Vale and from siderurgic in Barra Mansa, Rio, to pollute with metal dust two main cities, Barra Mansa and Vitória in Brazil. Now this is the big mouth of the ocean, as we call Fiedler ocean collector. This is the idea to collect floating plastic of the water surface. It's a membrane, and this is the very complex case of creating the cutting pattern for the very much organic shape of this restraining inflatable things. Here we have a little animation about it. It's here. Here starts. That's the idea. I heard, which is hearsay probably, that the Americans spent millions to make a pressurized pen to write on a space station, and because of gravity. Maybe it's just a story. And I heard that the Russians used a pencil, which is no millions necessary. The need was to write in space. And this idea is something very simple, and we have the need, especially for the Olympics in Brazil, to clean Guanabara Bay of millions and millions of plastic bottles floating, coming. And my idea is to create a new behavior. Imagine a strike of the garbage collectors in Paris, London, New York, São Paulo. In 3 days you have chaos, but we don't have garbage collection on the sea. So this idea is to have a sea broom and create the idea that every day the cities would have ocean debris collection. So it's an idea, very simple. It's a pencil. It can be towed by any boat, and it's a membrane. It's a tension membrane. It's structured by inflatable. We made very intense tests on CFD again of the flow inside when we have the nets below and the spinning inside to collect the debris inside. So we have this idea of making other uses of membranes, where we have the same algorithms we use to calculate a roof of a stadium. We have to use a membrane. It's a very hard cutting pattern of the inflatables to have it made and stabilized. That's the task of the moment. So I'm looking most of the time for new uses of the membranes. And when there was the accident of Macondo, we created, this is the idea. This is the cutting part of the easy part. We created this underwater funnel. Ferrari tested this material in the bathymetric chamber up to 2,500 meters deep. And the idea is to have every platform oil rig with one membrane guide. We did a test with Petrobras, and they are to be launched by torpedoes, and you guide it to the bottom of the sea. And we don't fight nature, we guide the oil bubbles up into a membrane receiver that has a separator of gas on top and water on the bottom, and each buoy like this can hold 1 million liters of oil that can be safely towed somewhere. So these are ideas of the membrane structure to help the environment, to protect the environment, and not only make roofs. We have the techniques to calculate, we have the machines to weld it, and we always need ideas and help. We are looking for names for the big mouth eating plastic. We don't have a good name for that. This is a very most complex calculation we did using CFD. This is a multi-phase calculation of 47% oil, 53% gas, methane, over a 2,500 meters riser of a flexible membrane, and we could prove the membrane resists the clogging pressure. And then we went to MIT on Petrobras account, and we had, after many days of discussions, where from the beginning we always had this difficulty of selling membranes. People would say this is plastic. And these oil rig guys, they think of heavy metal. Everything has to be hundreds of tons of steel. And I was having a really hard time with the guys in this big U table, and they seemed not to believe a membrane could resist, although they would see finite element calculations saying it would work, it would resist, the flow would happen. And then I was getting desperate because they always thought this is a plastic, it is a membrane, it's going to tear down. And then I said to the guys, what happens if 3,000 Red Bulls run over us now and we face it? We are run over the bulls. But tell me, you Yankees, how many cowboys do you need to guide 3,000 bulls? And they started really quarreling. And they agreed that 6 men on horse, only 6, could guide a herd of bulls into a fence. So then they started talking to me again, that this idea was not fighting the pressure of the eruption of oil of a broken rig, but we are only guiding the naturally floating bubbles of oil that have a density of 0.856 approximately and floats in water, and we were guiding the oil bubbles into this container. So these are 3 new tasks for membranes, helping protect our environment for our kids and grandsons. And this is what I'm dedicating now. And any of you who have ideas to collaborate, I'm very helpful and glad to hear. I got some ideas from Caruana a few days ago. He was visiting